Hi, today we're going to solve this exercise about geometric sequences for a student. So the first question says that the first three terms of a geometric sequence are natural logarithm of x to the power of 16, natural logarithm of x to the power of 6, natural logarithm of x to the power of 4 for x greater than 0. Obviously, if not, the natural logarithm wouldn't be defined. Find the common ratio. Okay, so this is very easy. You know that in your terms, you have the first term, second term, third term, etc. So the first term is logarithm x to the power of 16. The second one is logarithm of x to the power of 8. The third one is logarithm of x to the power of 4, etc. So that's our series. And we know the general formula for the nth term in a geometric sequence is the first term times the ratio to the power of n minus 1. So to solve this first part, we have to use either the second or the third term. We can't solve the first term because if we can't use the first term because if we use the first term, we would basically have u sub 1 is equal to u sub 1, 1 minus 1. So that gives us u sub 1 equals u sub 1, which is obvious. Okay, so we have to use either the second or the third term. Let's use the second one, that's easy. So I just write u sub 2 equals u sub 1. So u sub 1 was logarithm of x to the power of 16 times the ratio multiplied by, we're talking about the second term, so that's 2 minus 1, and that's going to be equal to logarithm of x to the power of 8. Okay, so, well, we know that logarithm to the power of 16, of x to the power of 16 can be written as 16 logarithm of x, and 2 minus 1 is 1, so that's r, and this is 8 logarithm of x. Okay, so we can divide by logarithm of x and then leave r as the leave r on its own. So that's 8 to the power 8 divided by 16. So that's 1/2. So the common ratio is 1/2. Very easy. We would obtain the same as if we did the exercise with u sub 3, which is this one is u sub 3. This one is u sub 2. This one is u sub 1. Remember that in sequences we start with 1. We don't start with u sub 0. Okay, careful with that because that's something that I used to have problems with when I was a student. Okay. So question B. And question B says solve this expression, which seems completely unrelated. But of course, if it's in the exercise, you have to be able to solve it. So let's see what we have here. So we have the sum when k equals 1 to k equals infinite of 2 to the power of 5 minus k times logarithm of x equals 64. Okay, so first thing that we can see here, this is a formula of the sum of k, and this is x, so, and it's multiplying. Okay, so basically you can extract logarithm of x out of that part because it doesn't depend on k. So you can say, you can rewrite this, which is much more simpler, as 2 to the power of 5 minus k, and only leave here, and I'll put it like that, the terms that depend on k. If it doesn't depend on k, you can extract it out of there. Okay, so now second, the hint here is that you have from the sum from 1 to infinite. So that's what we know of, and that's what we know as the sum of the infinite terms. And there's a formula in geometric sequences that says that sum of the infinite terms equals the first term divided by 1 minus r, and it's important here that the modulus of our r has to be less than 1. Okay, So let's just rewrite the parentheses in another way. So we have sum k equals 1, k equals infinite. That's 2 to the power of 5 times 2 to the power of minus k. And that can be written as the sum k and 1, k and infinite. 2 to the power of 5 is 32. And again, 32 doesn't depend on k, so we can extract it from the sum okay. And this over here can be written now and again this can be written, you can see it more clearly as okay. And this is a geometric sequence with ratio 1, common ratio 1, which is smaller than 1. Okay, so we can use the formula of the sum to infinity. So the sum to infinity of only this part over here is going to be first term. So if we have the first term, that's 1 divided by 2 to the power of 1. Okay, so if we have this series here, the first term is a half to the power of 1, which is half. Second term is a half to the power of 2. Third term is a half to the power of 3, etc. So the first term is a half. And then we'll have 1 minus, and the common ratio is a half. So that's 1 divided by 2 times 1. This half is this one. A half minus a half is 1/2. And 2 divided by a half is 1. So the sum to infinity of that series is 1. Okay? And you have to realize that this part over here is the sum to infinity. We're adding up from 1 to infinity to is the sum of to infinity. We're adding up from 1 to infinity that series. Okay? So again, this formula over here can be written as logarithm of x, and then 2 to the power of minus 5 could be written as 32 times that sum. So that's 32 times, and we've said that the sum to infinity was 1. And that was equals to 64. Okay, so let's go back to this. This logarithm of x is this logarithm of x. 32 was obtained by rewriting this part over here and extracting 32. And then that left us the sum to infinity. So that's that 32. And the 1 we calculated here as the sum to infinity, which was 1. You can go back through the video and see what we've done there. Okay, so what does this mean? 32 times logarithm, that has to be 64. So what does this mean? 32 times logarithm of x equals 64. Logarithm of x equals 2. And then the base of the logarithm is of the natural logarithm is e. So remember the formula of the logarithms, the definition, which says logarithm in base a of b equals c, therefore a to the power of c equals b. So the base here instead of a is e, so e to the power of 2 equals x. So that's my answer. Okay? Hope it helps. If you didn't quite understand something, go back to the video and see what I've done. Remember that this was the formula we needed to solve in the exercise. I just divided it into different parts. I first rewrote the sum to infinity and obtained this part over here, and then I extracted just the sum and obtained it was 1. Okay, so this one is this green part over here. Yep, and then I reunited everything here. Okay.